Hello, class. This is Coach Kindig. I am so sorry that I cannot be with you today, but I have a very important meeting that is going to take me all morning. So I am in the building, but unfortunately I'm not in class with you today. But have no fear, class will go on. How this will work is you will just go through your notes that you have with you while I take you through the slides, and you will take notes as I write. And sometimes you will just listen along, but follow along as I go through these notes, and then we will have a few review slides at the end where you will get to practice what we have introduced to you, and that will be it. Be looking out for an email from me that you should receive this morning that will have your adjusted homework assignment. Remember, if you look on your homework sheet, that homework is not correct. It has too many problems for you to do, so make sure you are looking out for an email from me that will have the exact homework problems that you are supposed to do. So without further ado, we will go ahead and get started on Chapter 6, Section 4. So go ahead and take out your notes and go ahead and have something to write with so that you can start taking notes. Okay. Chapter 6, Section 4 is about special quadrilaterals. So we're continuing with the theme. If you remember, Chapter 6, Sections 2 and 3 were both about parallelograms. So a parallelogram is a special type of quadrilateral that we have already introduced. In this chapter, we will introduce more parallelograms, but that even have more specific names. So we will go over those now. The first one you can see there is a rhombus. And a rhombus is a parallelogram, so that means the opposite sides are parallel, with all four sides being congruent. Now, think about this for just a second. It is a parallelogram, so that means all of the rules that we learn in both sections 2 and 3 still apply to this shape. So these opposite angles here are congruent. Angles B and angles D are congruent. Angles A and angles C are congruent. A and B are consecutive, so that means they're supplementary. B and C are consecutive, so that means they're supplementary, so on and so forth. And their diagonals bisect each other. So all of those things are still true because this is a parallelogram. The only difference between a just regular parallelogram and a rhombus specifically is that a rhombus is a parallelogram that has all four sides congruent. Notice, this is not a square. What about this shape do you notice that is different than a square? Think about that for a second. I'm going to give you about 10 seconds of silence just to think about what is different about this shape than a square, because a square likewise has four congruent sides. So what makes a rhombus different than a square? Okay. What makes it different than a square? Well, we will see in a second, but I hope your hunch is correct. The next one, the next shape that we will go over is a rectangle. A rectangle is a parallelogram with four right angles. So notice it says nothing about the sides. The only stipulation is that the opposite sides are parallel and that all of the angles are right angles. Notice once again, it is a parallelogram. So all of our normal rules for a parallelogram are also true. And then the last one, of course, is a square. A square is a parallelogram that has four congruent sides and four congruent angles. So it is like a combination of a rhombus and a rectangle because the sides are congruent, but also the angles are all right angles. So what is different? What is the difference between a rhombus and a square? Well, you can see that a rhombus doesn't have four right angles as their angles, whereas a square has all four angles are all right angles, which means they all equal 90 degrees. So that is a rhombus, a rectangle, and a square. Once again, those are all special quadrilaterals, and you will also notice that those are all parallelograms. So there are some corollaries here, meaning this is basically the word definition for what these are, what these special quadrilaterals are. We can only have a rhombus if and only if it has four congruent sides. So a rhombus is a rhombus if and only if it has four congruent sides. And we can say something similar about a rectangle. A quadrilateral is a rectangle if and only if it has four right angles. Now follow this theme with me. We have the rhombus corollary. we have the rectangle corollary, which are no different than what we just saw on the last slide. We saw picture versions of them on the last slide. This slide, we are just putting that exact definition into words. So a quadrilateral is a rhombus if and only if it has 4 congruent sides. That's the only way a rhombus can exist. A quadrilateral is a rectangle if and only if it has 4 right angles. What do you think the corollary for the square will be? Take about 10 seconds and think about that to yourself. And as I'm sure you guessed or just read on the slide below, a quadrilateral is a square if and only if it is both a rhombus and a rectangle. What do those things mean? Well, a rhombus has to have 4 congruent sides and a rectangle has to have 4 congruent angles. So a square, like we said earlier, is a combination of being both a rhombus and a rectangle. It has 4 congruent sides and the angles are all right angles. Okay, so what we are going to do now is we're going to go through some true-false questions. What I want you to do is I'm going to go ahead and click over to the next slide, and you will see all of these here. I want you to go through these one at a time, and I want you to just write true or false. I'm going to give you a second to pause the video, and when you pause the video, I want you to go through all 7 of these. Work with the person next to you. So wait till they are at the same point in the video as you are, and go ahead and do each one of these. These will be very important for your understanding of each of these shapes, because it's important that you understand what the difference between them is, because sometimes it may seem that kind of simple. Sometimes it gets a little hairy, so know that. So go ahead, pause the video, get through these 7 in your notes, and only when you've completed all 7, go ahead and continue on. All right, now that you have completed all 7 of these, let's go through these really quickly. I'm going to get my writing tool out here. Yep, that's what I want. We'll go with green. True or false, a rectangle is a square? Well, that, of course, is false. Why? That's because a rectangle does not stipulate that it has to have 4 congruent sides. So we could go in reverse and say that a square is a rectangle because a square must have 4 right angles. But a rectangle does not have to be a square. So a rectangle is not always a square, and that makes this statement false. A square is a rectangle. Where we just said it. A square, true, will always be a rectangle. By definition, a square must have 4 right angles, and so therefore a square will always be a rectangle, but as we just said in number 1, a rectangle will not always be a square. A rhombus is a rectangle. That is false. Why? Nowhere in the definition of a rectangle does it talk about the sides of the rectangle having to be congruent. Those are 2 different things. A rhombus has to have 4 congruent sides, but there's no stipulations on the angles, whereas a rectangle only has to have 4 right angles. So a rhombus is not a rectangle. A rhombus is likewise not a square. Why? Because a square has to have 4 congruent sides and 4 right angles, which means that a rhombus, there are plenty of ways I could draw a rhombus where it would not have 4 right angles as its angles. So a rhombus is not always a square. So that statement, a rhombus is a square, implies a rhombus is always a square, and that is false. A rectangle is a rhombus. If you guessed false, that is also true. A rectangle does not have to have 4 congruent sides, which a rhombus must. So a rectangle is not a rhombus. A parallelogram is a rhombus. That is also false. Think about that for a second. Can I draw a parallelogram that is not a rhombus? In other words, can I draw a parallelogram that does not have 4 congruent sides? And the answer to that question is yes. there are plenty of ways that I could draw a parallelogram that does not have 4 congruent sides. Think about it. A rectangle is a parallelogram that does not have 4 congruent sides. So a parallelogram is a rhombus. That is false. A square is a parallelogram. That will always be true. That will always be true. A square will always be a parallelogram. And in fact, a rhombus, a rectangle, and a square, that statement would be true for all of those things. A rhombus is always going to be a parallelogram, a rectangle is always going to be a parallelogram, and a square is always going to be a parallelogram. Okay, so we have one more of these slides. So what I want you to do is I want you to go through and I want you to simply write 1 through 7. Is this sometimes, always, or never true? Is a rectangle always, sometimes, or never a square? Is a square always, sometimes, or never a rectangle? So on and so forth. This is like a little bit deeper step of critical thinking. So once again, I want you to wait till the person next to you is at the same place that you are. Pause the video and go ahead and work on these together. Come up with an answer to every one. Don't write nothing. That's not participating. Go through every single one of these and write sometimes, never, or always. And if you get one wrong, don't just say, man, I got it wrong, and then move on. Think about what you got wrong and why you got it wrong. So go ahead, pause the video, work through all 7 of these, and then we will move on. Okay, here we go. A rectangle is a square. Here's what you have to think. Here's how you should think through each of these. Is there any case where this is true? Is there any case where this is not true? Here's why. Can I draw a rectangle that is a square? Yes, but will a rectangle always be a square? That, of course, is no. So we've crossed out always for number 1. Number 1 will not always be true. Will a rectangle sometimes be a square? The answer to that is yes. It will sometimes be a square because a square by definition is a rectangle. So if a rectangle is a square, then this would be true. But there are plenty of rectangles that aren't squares. There are plenty of rectangles that don't have 4 congruent sides, so that is sometimes true. A square is a rectangle. Well, think about what the definition of a rectangle is. The definition of a rectangle is that it is a parallelogram that has 4 right angles. Well, does a square always have 4 right angles? The answer to that is yes. So a square will always be a rectangle. Always be a rectangle. Moving right along, a rhombus is a rectangle. Is there any rhombus that I can draw? Remember, a rhombus means 4 congruent sides. That is a rectangle. Well, what is a rectangle? A rectangle has 4 right angles. So is there any rhombus that I can draw, a quadrilateral with 4 congruent sides that has 4 right angles? The answer to that is yes, but will a rhombus always be a rectangle? No. Look at the one back on our first slide here. This is not a rectangle because the angles are not right angles. So there are plenty of ways to draw a rhombus that is not a rectangle, but a rhombus sometimes will be a rectangle. And the only instance when a rhombus would be a rectangle is, of course, a square. A rhombus is a square. Once again, that is sometimes. If the rhombus has 4 right angles, then it is a square. But a rhombus does not have to have 4 right angles, so that will not always be true. It will sometimes be true. A rectangle is a rhombus. Let's think about that for a second. A rectangle, 4 right angles, will be a rhombus. Will have 4 congruent sides. That's not always true because there are plenty of rectangles I could draw without having 4 congruent sides. But it will, once again, sometimes be true. It is possible to draw a rectangle that is a rhombus, and once again, that is a square. A parallelogram is a rhombus. Think about that. If it was to say that a rhombus is a parallelogram, that would always be true, right? Because by definition, a rhombus is a parallelogram that has 4 congruent sides. But does every parallelogram have to be a rhombus? The answer to that is no. So once again, it's not always, but a parallelogram will sometimes be a rhombus. And then like we just said, a square is a parallelogram. Well, that is in the definition of a square. There's no way I can draw a square without it being a parallelogram. So this one is always true. All right, so maybe you did well on these, maybe you didn't. Regardless, I hope that this was a useful exercise in you having to think a little bit outside of the box and really compare these different types of special quadrilaterals to each other. Okay, so here's an interesting thought. These are all parallelograms. So what does this have to do with their diagonals based on if the quadrilateral is a rhombus, a rectangle, or a square? Well, we're going to go through a few theorems that are going to talk about that really quickly. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So here's what that is saying. This angle right here, I'll draw this in green once again. If it is a rhombus, anytime we have a rhombus, that intersection right there will be perpendicular, meaning it'll form 4 right angles. So anytime we have a rhombus, once again is a parallelogram that has 4 congruent sides. The diagonals will be perpendicular to each other. Okay, well, also dealing with a rhombus, a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Okay, that one is kind of confusing, so let's talk about that one a little bit more in detail. Both of these are dealing with the diagonals in a rhombus. The diagonals in a rhombus, we know that a parallelogram is a rhombus if, like we just said in Theorem 6.11, this is a right angle. Well, another way we can tell that a parallelogram is a rhombus if we don't know that all of the sides are congruent. Once again, in these pictures, it does not show that the sides are congruent. So we are using other means to prove that this is a rhombus. One other way we could prove is if each diagonal bisects a pair of opposite angles. Here is one angle, and what this is saying is that this diagonal is bisecting both angle B and angle D. So it's cutting these angles perfectly in half. So that angle right there is congruent to that angle. And this angle right here is congruent to that angle. Likewise, I'll draw these over here. This angle, because it's being cut in half by this diagonal, is congruent to that one. And I'm not going to draw this one down here, but you get the picture. This angle here will be congruent to that angle there because it is a rhombus. And lastly, diagonals of a rectangle. In a rectangle, the diagonals will be congruent. So AD, this diagonal AD, that's a segment, will be congruent to this diagonal BC. That's in a rectangle. Okay? So think about, what does this have to do with squares? What can we determine about this based on a square? Well, a square is a parallelogram and a rhombus, so all of these things would be true. Theorem 6.11, Theorem 6.12, and Theorem 6.13 would all apply to a square. Why? Because it's both a rhombus and a rectangle. But if it's just a rhombus, then we know that the diagonals form a perpendicular intersection, and then it bisects each of the angles. But only in a rectangle will the diagonals be congruent. Okay, that is it for today. That is all the notes that you have today. Like I said, I will be sending you an email that has the specific exact homework problems that you should do. So don't refer to your homework sheet because those problems are wrong and you will do too much work. I hope that you found this fruitful. If you have a question on anything in the notes from today, you can go back and watch that section of the video again. Maybe you zoned out, or maybe you just need to hear something a few more times. That is fine. That's the great thing about taking notes like this, is you always can go back to the video and watch it again. Sometimes it takes 3, 4, 5 times of hearing something before it finally kind of locks in. So watch the video if you have any questions. You can also email me if you have any questions. Other than that, I hope that you enjoyed this. I hope that you got to experience math a little bit differently today than you do in the past, and good luck on your homework.